Hello, today I will be discussing about the properties of estimators and properties of estimators, especially the blue. Okay, now at first there is a question: what is the estimator? For example, you can take an example, and there is a population, and population has a mean and variance, and it is it is not known to us, it is unknown to us that mean and variance of the population. So if we take a sample from this population and find the mean and variance, this mean and variance of the sample is called the estimator. Well, and suppose you have to collect some data from the population of India, and you select suppose 500 individual, and the total number of population, and it is from this it is its mean and variance. It's very difficult to find out, so in this aspect we consider it as unknown. And the sample that you have taken, 500 individuals, and that has, and you can estimate the mean and variance. So the sample of 500 individuals, mean and variance are the estimators. And here you should remember that this is the statistic. Okay, this is the statistic. Estimators is also called the statistic. Now, now there is two types of estimators. One is point estimators and another is interval estimators. What is point estimators? When you estimate and you get the single value of the sample mean. Sample mean is estimated, and you get is one value of the estimated, then it is called the point estimated. Okay, and what is the interval estimator? An interval estimator is that when you estimate the mean and variance of the sample, then the value of the estimator will lie within a range. Within a range, it is, suppose it is less than B and greater than A. Suppose it is less than B and greater than A. So within the range A and B, the value of the estimator lies. So this is the interval estimator. Okay, so there are two types of estimators. Now, the blue. What is the blue? Blue is the B stands for best, and L stands for leaning, and U stands for unbiased, and E stands for estimating. Okay, so this is the blue. So blue, here the linear. Here L represents the linear. Linear means, suppose the mean of 1, 2, 3, 4. For example, you can take 4. You have to find out the mean of 1, 2, 3 and 4. Okay, 4, and you have to find out the mean of suppose the mean of this 1, 2, 3, 4, and you have to find the mean of these values. So mean of these values is 1 plus 2 plus 3 plus 4 divided by 4. So mean is the mean. Here it is a linear. Here it is a linear. So estimated here, the estimated is x bar. X bar is a linear. Okay, so this is the linear. It means the estimated is linear. So it means this. And unbiasedness. What is the unbiasedness? Now it means the minimum variance. The variance of the estimated is minimum. So it is the it is the it represents the E. It represents the E. That means the efficient variance should be minimum. In that case, it is efficient. Efficient estimate. And unbiasedness, U stands for unbiasedness. Unbiasedness means if we increase the number of observation, then it will be it will be unbiased. For example, suppose the expectation of the estimator and expectation of estimated is equal to the parameter. The parameter. Okay? Estimated, estimated, it means suppose estimator of a sample, you can say estimator of beta hat. Suppose beta hat equal to beta. This is the population parameter. This is the population parameter, the sample parameter. When the expectation of beta hat is equal to beta, then it is called unbiased. It means expectation of beta hat minus beta, the population parameter, equal to 0. It represents the unbiasedness. Okay, this is the best linear unbiased estimating. Now, now now unbiasedness. Now unbiasedness. Look at this. Look at this very carefully. What is the unbiasedness? Look, along this vertical axis we measure the probability, and along the vertical horizontal axis we measure the values of the variable. So this is the normal distribution of a sample. It is bell shaped. Okay, it is a normal distribution. It is a normal distribution, and here is the suppose beta hat equal to beta. Here you can write suppose Suppose this point represents the beta hat equal to beta. This means the estimator is equal to the parameter. This point represents. Okay. So this is this is represents the unbiasedness. As I have proved in my previous slide, that unbiasedness means expectation of beta hat is equal to beta. Estimator is equal to the parameter. So this point represents the estimator is equal to the parameter. Okay. And now this distribution, look at this distribution. This distribution has this distribution has another beta hat, which is not equal to the beta. Okay. Here there is a difference between the estimated and the parameter. For this sample, for this distribution, there is a difference between the estimated and the parameter. That is, beta hat is not equal to the beta. Beta hat is the estimated and beta is the parameter. So this is the pictorial presentation of unbiasedness. Unbiasedness. This is the unbiasedness. This this bell-shaped curve represents the unbiasedness. Plus this bell-shaped curve represents the biasedness. Okay, this is the biasedness. Now, look here. You can find another picture, and here we can try to clarify the unbiasedness and small variance, unbiasedness and large variance, biased small variance, biased and medium variance, biased and large variance. So at first, the A, this distribution, the A distribution, and this distribution is the B distribution. Okay, this is the B distribution, and this is the C distribution, and this is the C distribution, and this is the E distribution, and this is the D distribution. And A distribution represents the unbiasedness because parameter is equal to the estimated. This point represents the parameter is equal to the estimated, and 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 parameter equal to the estimated, and here for B distribution, sample distribution, it is unbiased, also unbiased because beta hat equal to beta, but the variance is large. Variance is large. You can find the variance is large. But look at this. Here beta equal to beta hat. Here beta hat equal to beta. But here this distribution C distribution, beta hat is not equal with the beta population parameter. So it is unbiased. So it is biased. Okay. So it is biased. And you can find the variance is small as you can find it for distribution A. Okay. For distribution A, you can find the variance is small. Here also variance is small, but it is unbiased. So it is biased. And similarly, and you can see the medium variance. You can find the medium variance for D. The distribution D represents the medium variance, but it is biased because the estimator is not equal with the parameter. Now, the distribution E represents the bias and also loss variance is there. Biased and large variance. You can find the biasness. You can find the biasness because also the estimated is not equal to the parameter. This point represents the estimated is equal to the parameter. But this point does not represent the estimator is equal to the parameter. So it is biased and variance is high, is large. So the distribution E represents the biased and large variance. So in this lecture, I try to clarify the the blue, that is the best linear unbiased estimated, and I try to clarify with the pictures, with the diagram, and what is the unbiasedness, what is the biasness, and when there is a biasness and when there is a large sample, large variance, and when there is unbiased and small variance, and when there is biased and large variance, and biased and median variance, is all type of situation I have tried to represent with the pictures. So yeah, it can be very clear, and you can understand in better way. So thank you very much for enjoying this lecture.